In this lesson, we are going to learn about the difference between theoretical probability and experimental probability. Theoretical probability is what we think should happen in a certain situation. So I'm going to write down what we think will happen. Oops, sorry. Will happen based on the possible outcomes. And I will show you some examples of this in just a second after we get the definitions down. So theoretical probability is what we think will happen based on the possible outcomes. So I always think theoretical, think, okay? Experimental probability is what actually happens when we test the situation. So what actually occurs when we test the situation. Okay, so again, theoretical is what we think will happen. Experimental is what actually happens. So let's take a look at some examples. Okay, so rolling a 6-sided dice 10 times. So it says, what is the theoretical probability? So again, theoretical is what we think will happen. So what's the theoretical probability of rolling the number 5? Well, on a number cube, there's one side that has a 5 on it out of 6 total sides. So we would say that the theoretical probability is 1 out of 6, or in other words, 1 divided by 6. When we divide it, we get 0.16 repeating, which is the same as 16.6 repeating percent. So we would say that the theoretical probability is 16.6 repeating percent. For experimental probability, we're talking about what actually happens when we test it. So let's say I'm going to roll the dice 10 times. I'm going to make myself a little chart here. 1, 2, 3, 4, 5, 6. And I'm going to keep track of how often I roll the dice, and or which numbers I roll. And I'm going to roll the dice 10 times. So you'll hear me rolling the dice. Unfortunately, on the video, you won't be able to see it. Okay, I just rolled, and I just got a 1, a 3, another 1, a 6, a 3, a 5, a 5, a 6, so let's see, that's 8 so far, a 2, oops, and another 2, okay? So according to this data, the experimental probability is how often did I actually roll a 5. So you can see here that I rolled a 5 2 times out of the 10 times that I rolled it. This simplifies to 1/5. And if I divide 1 by 5, I get 0.2, which is the same as 20%. So the experimental probability was 20%. So notice that they weren't exactly the same. What actually happened was not necessarily exactly what we would predict. It was very, very close. All right, so the next question, what's the theoretical probability of rolling a prime number? So again, theoretical is think, what we think should happen. On a number cube, the prime numbers are 1, 2, 3, and 5. Remember, prime numbers are numbers where you can only multiply the number by 1 in itself to get that number. So 4 isn't prime because 2 times 2 equals 4. 6 is not prime because we can do 2 times 3 to get 6. So these are the prime numbers right here. So theoretical probability means there are 4 possibilities of prime numbers on a number cube out of the 6 total sides. This, I can divide them both by 2 and I get 2/3, so it simplifies to 2/3. When I divide that in my calculator, I get 0.6 repeating, and that's the same as 66.6 repeating percent. So the theoretical probability is 66.6 repeating percent. For experimental probability, again, it's what actually happened, okay? What actually happens. So if I go back up to my example up here of when I actually rolled the dice, how many times did I actually roll a prime number? Well, I rolled a prime number. Let me get a different color here. This is prime, this is prime, this is prime, and this is prime. So I actually rolled a prime number 8 times out of the 10 rolls that I rolled. So 8 and 8/10 can be divided, both of them can be divided by 2, and it simplifies to 4/5. When I divide it, I get 0.8, which is the same as 80%. So experimental probability says that I would get a prime number 80% of the time. That's what actually happened. Again, notice that experimental and theoretical did not necessarily match. So this says, draw from a deck of cards 10 times. Okay, so the first question says, what is the theoretical probability of drawing a heart? So if you're not familiar with standard decks of playing cards, there are 13 cards in every suit. So I'm just going to write suit over here, and that's 13 cards in every suit. There are 4 total suits, so that means there's a total of 52 cards in a deck. Okay, so the question is, what is the theoretical probability of drawing a heart? So there are going to be 13 hearts in the deck out of 52 total cards in the deck. So theoretically, I would get a heart 13 times out of 52. Now, you can divide each of these by 13. 13 divided by 13 is 1, and 52 divided by 13 is 4. So this simplifies to 1/4, which is 0.25, or 25%. So theoretically, what we think should happen is we should get a heart 25% of the time. For experimental probability, it's what actually happens, okay? So what I'm going to do is keep track of, I'm going to write hearts, diamonds, spades, and clubs. And I have a deck of cards here. Again, you're not going to be able to see it, but I'm going to draw 10 cards and see what I get. So the first card, I got a heart. Another heart. This time I got a diamond. And another diamond. Next I got a club. A diamond. A diamond. A heart. A club. A club. Let's see, I have 3, 7, actually that's 10 right there. Okay, so the experimental probability of drawing a heart, I ended up getting 3 hearts out of 10 draws. So my experimental probability is 0.3, which is 30%. So you can see it was close to the theoretical probability, but not exact. All right, the next one says, what's the theoretical probability of drawing a king? Okay, well, in a deck of cards, there are 4 of every number. 4 kings, 4 queens, 4 4s, 4 8s, 4 10s, 4 of everything. So theoretical probability of getting a king would be 4 out of the total number of cards, which is 52. To simplify, I can divide these both by 4. And when I do that, I get 1 out of 13. So the theoretical probability of getting a king is 1 out of 13, which is 0.0769, etc., which is the same as about 8%. So I think I should get a king about 8% of the time. So now, if we do experimental probability, that's how often did I actually get a king. Okay, so I'm going to do this experiment again because I didn't keep track of what actual cards I was drawing. And I'll see out of 10 how many times I actually get a king. So I'm going to make myself a little chart for king, okay? And then we'll do queen, jack, and then we have 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1 would be your ace. And I'll keep track of what I get. So let's do this again. So I got a jack, another jack, a 9, oops, a 3, a 10, a 6, an ace, a 7, a 9, so let's see, I have 5, so I need to draw one more, it looks like, an ace, so that's 2, 3, 4, 5, 6, 7, 8, 9, 10, so there's 10 right there. So to figure this out, how many times did I actually get a king? Well, if you look at king, I didn't get a king at all, so I got a king 0 times out of the 10 times that I drew, so that would be 0%. So in my experimental probability, I got a king 0% of the time. Again, notice that does not necessarily match what I thought what would happen, or my theoretical probability. So those are some examples of experimental versus theoretical. Theoretical is what you think should happen. Experimental is what actually happens.